In this video, I'm going to just walk you really quickly through how to use the lens formula that you took in your notes yesterday. So this first problem is pretty straightforward. This is number 1 on your handout. An object is placed 8.0 centimeters in front of a converging lens. A real image is produced at 12 centimeters. Find the focal length of the lens. Now, a converging lens is one that has light rays converge in front of the lens, so it's a convex lens. Now, looking at the problem here, the box asks you for given and unknowns, for the equation, to substitute, and to solve. GUESS, going back to that. So let's first look at our givens. An object is placed 8.0 centimeters in front of a converging lens. So that's the object placement. That's how far the object is. DO equals 8.0 centimeters. A real image is produced at 12 centimeters. So the image shows up here. That would be our DI, our image distance. 12 centimeters. And what we're finding is the focal length. So our unknown is F, focal length. So let's just rewrite that there so it's a little easier to read. The equation we're going to use is just exactly as written. 1 over F equals 1 over DO plus 1 over DI. Now it's pretty straightforward to start with. We're going to just plug in our numbers here. 1 over F equals 1 over DO, which is 8.0 centimeters, plus 1 over DI, which is 12 centimeters. And we can't just add 1 over 8 plus 1 over 12. We need to find our lowest common denominator. So the lowest number that 8 and 12 will both go into, which is 24. So we know it's going to be something over 24 centimeters plus something over 24 centimeters. Now, to get 24, we multiply this by 3. 3 times 1 is 3. 3 times 8 is 24. To get this one to 24, we multiply by 2. 2 times 1 is 2. 2 times 12 is 24, as we have down here. Now we can just add the top number of our fraction. 3 plus 2 gives us 5 over 24 centimeters. And some people will just stop there, but we're not finished yet, because 5 over 24 centimeters is equal to 1 over F. So we have to do one more thing, and that is flip our fraction. So we need to flip it over, and we get 24 centimeters divided by 5 is going to equal our F. So when you put that in the calculator, 24 divided by 5, you get 4.8 centimeters. And there is your answer. I'm going to do one more example problem. Now this one is number 2B on your paper. A 15 centimeter object is placed 45 centimeters from a convex lens, which has a focal length of 15 centimeters. Use the thin lens equation, or the lens formula, to find the image distance. So let's look at our givens again. This 15 centimeter object, that's telling you how tall the object is, or the object height. Now we don't actually need that for this equation. That's an additional piece of information. What we want is this one. It's placed 45.0 centimeters from the lens. So that's going to be our object distance, our DO. 45 centimeters. The focal length of the lens is 15 centimeters. So F is equal to 15 centimeters. What we're looking for is the image distance, so our unknown in this case is DI. So when you go back to your equation, 1 over f equals 1 over dO plus 1 over di. Well, I want my di all by itself. I want this alone. So I'm just going to subtract my 1 over dO from my 1 over f. So I get this. Let me rewrite the equation for you here in blue. 1 over di is equal to 1 over f minus 1 over dO. So that's the equation that we're going to be working with. Since we're looking for di, we're going to subtract the other two. Now we can substitute. So we know that 1 over di is equal to 1 over f, which is 15 centimeters, minus, let me erase that, minus 1 over our dO, which is 45 centimeters. And we need lowest common denominator again, which in this case is already 45. So to make this one match the 45, I multiply by 3. And I get 3 over 45 centimeters minus 1 over 45 centimeters. 3 minus 1 is 2 over 45 centimeters. And we're going to do exactly what we did before, because 2 over 45 is equal to 1 over our di, our image distance. We want to flip that. And we get 45 centimeters divided by 2. When you plug that in your calculator, you get 22.5 centimeters. So the image is going to appear 22.5 centimeters beyond the lens. Watch the videos again if you are unclear on anything or ask for help. But good luck and do your very best.